We are solving two simple questions in semiconductor devices that appeared in the NEET examination in the previous years. Let us see what are the questions are. Out of the following, which one of the diodes is a forward biased connection? So the first thing that you need to understand, for a diode to be forward biased, in forward bias, positive plate of battery has to be connected to p-type material and negative plate of battery has to be connected to the n-type materials of the semiconducting material device. So a semiconductor device is shown symbolically like this. This is p-type, this is n-type. So if we connect it in this way, like this is positive and n-type is negative, this diode is in forward bias, where the V input must be greater than V barrier potential so that the current flows in a forward bias. In the other sense, there shall be high voltage at the p-type than the n-type. But look at the options that are available to you. This is minus 2 volts, this is minus 4 volts. So it's very clear that in option A, voltage that is available at the n-type is greater than voltage available at the p-type, because this is minus 4. Minus 4 is less than minus 2. Look at the second option B. This is 2 volts and this is 5 volts. Again, V at the negative mean n-type metal is greater than connected to the p-type. This is minus 2 plus 2. That's the same condition even for the C also. But look at the D. This is 0 volts minus 3 volts. So it's very clear that 0 volt is definitely greater than minus 3 volt. That means voltage available at the p-type material is greater than voltage available at the n-type material. That means the D that was given for you is in forward bias. So which one is in forward bias means this one is in forward bias. That's how we solve that simple question. Let's have a look at the next question that is there. An intrinsic semiconducting material is converted into n-type extrinsic by doping what? So first of all, we shall know what do you mean by intrinsic. A semiconducting material is said to be intrinsic when it is having number of electrons equal to number of holes. So that's a pure semiconducting material where the major current that is passing to the net current passing to that is equal to 0. At an ordinary circumstances, you have to raise the temperature for it to pass the current, which is not practical. So we do a phenomena called doping. Doping is adding a small amount of impurity so that they can be converted into a material that has either number of electrons more than number of the holes. In that case, that is called n-type material, or number of holes much greater than number of electrons. In that case, that is called p-type material. These two are two types of semiconducting materials after doping, and they are called extrinsic semiconducting material. Now, if we have to convert this into n-type, we have to add in such a way that number of electrons has to be more than number of holes. You know, a semiconductor device is, a pure semiconducting like silicon or germanium has 4 valency electrons. So you shall add a doping that has 5 valency electrons, so that this 4 will form a bond with the other 4 covalent bonds, and the 5th one becomes a free electron. Thus this free electron, because of when you add few elements, there will be more free electrons. There is extra free electrons, that kind of material is called n-type material. So for getting n-type extrinsic, you shall add a material that has 5 valency electrons. Phosphorus is someone among the given options that has 5 valency electrons. and hence that's the answer for the problem. That's how we solve this problem. Thank you for watching.